Welcome to the sixth video of real numbers of standard 9. In the previous video we have seen how to solve question number 1 and 2 from practice set 2.2. Now we are going to solve next question from practice set. Now in question number 3 it is asked to show square root of 5 and square root of 10 on the number line. Okay, whenever we want to show such irrational numbers on the number line, how to do? Actually we have studied this part in previous class standard 8, but still we are going to recall it quickly. First we have learned how to show square root of 2 on the number line. Okay, on the number line. For this, all these things we take help of right angle triangle and Pythagoras theorem in it. So in a right angle triangle, when we have this right angle, this we call as hypotenuse, okay, and this can be called as base and this can be called as height. Okay, suppose hypotenuse is shown by the capital letter H, base is shown by small letter B, and height is by small letter h. We know that hypotenuse square is equal to base square plus height square. Now on a number line, whenever we draw a line using the ruler scale, any point we can put it as it is at origin and we can say its coordinate is 0. Now taking equal distance, okay, with the use the compass, you can, I don't have a compass, so I am just taking it here like this. So if these two distances are equal distances, okay, so if this is 1, I can mention this is 2, and having the same distance on the left side also, we can have this is -1 and -2. So we know this is a number line showing integers this is 0, 1, 2 and -1, -2. Now you suppose here if you want to show that irrational number like this, we have learned to show square root of 2 on the number line. Now how to how this concept is going to be helpful to us. Now we know that as 2 is equal to what? 1 plus 1. So 2 is a square of what? 2 is a square root of 2. And then 1 is a square of what? 1 is a square of 1 itself. And this 1 is also square of 1 itself. So if your hypotenuse, if you want to be square root of 2, your base should be 1 and the height should be 1. So what we do, we try to draw a right triangle where the base is 1, height is 1. If your base is 1 and height is 1, you get your hypotenuse to be square root of 2. So what we do, we draw a right angle at this 1 coordinate. Okay, this is right angle. Suppose we have joined this and drawn this at right angle. Then what we do, we take the distance, whatever we have taken for unit 1, same distance we take it here. Okay. So this distance, if this distance is 1, this is also 1. So we have taken base 1 as well as height 1. And when we join these 2 points using scale, we get this distance square root of 2. Because 1 square plus 1 square is equal to square of root 2. Okay. So this way we have learned to show the square root of 2. Now if you want to show square root of 3 on the number line, how we have to do? Now as we know 3 is what? 2 plus 1. Now 3 is a square of 3. Okay. And then 2 is square of what? Square root of 2. And 1 is square of itself. So if you want this to be square root of 3 here your base should be square root of 2 and height should be 1. So here one thing left, that we got this distance 2, but we have not yet shown square root of 2 on the number line. For this you have to keep your compass pointer here, take this much distance in your compass and then have an arc over like this with this radius, and when it intersects here at number line, this distance is going to be square root of 2. Okay. So now that square root of 2, we have got it on the number line. Now to show square root of 3, we want a triangle where the base should be square root of 2 and the height should be 1. So now you can put the protractor here, keeping this as a center or middle point. Now have a 90-degree distance, join this, draw this angle, right angle. Now your base, new triangle is square root of 2. And the height is what? It is going to be 1. Okay. So this is 1, 1. Okay. Now when you join these 2 points with origin and this new point, you get this distance square root of 3. Okay. And then this distance taking as a radius, you can draw this, mark this, and this is going to be root 3. Okay. So you have learned this in the previous classes. Now from this basic knowledge, this basic information, how can you show square root of 5 and square root of 10 on the number line? For this, how we can bifurcate this 5? 5 can be written as 4 plus 1. Okay. So 5 is the square of irrational number square root of 5. And 4 is the square of what? We know the square of 4 is the square of 2. And 1 is 1 square. So what should be your base? This should be your base. This should be your height. So you need a triangle where, right angle triangle, where the base is 2 and height 1. If your base is 2 and height 1, you can get your hypotenuse as square root of 5. Or in other way, you can have base, you can replace this as this can be base and this can be height. Anyway, so one of the sides forming right angle should be 2 and the other can be 1. Base 2, height 1, or base 1, height 2. Okay, so like this you can draw. Okay. For this you take another figure, another number line. So taking with the help of compass, draw have equal distances between this -1, -2. Now for this, what do you want? Base 2. So from 0 to 2, you have this base 2. And the height, you can draw a right angle over here. And height we want 1. So whatever this distance you have 1, mark it here like this. Okay, I don't have geometric instruments with me now. That's why I'm showing it. But I'm sure you can understand this much, whatever we are doing. This is height is 1. And now when you join these 2 points, this distance is going to be 2 square plus 1 square. That is 4 plus 1. That is 5 and square root of 5. Now take this much distance in your compass and then have an arc. Wherever it will intersect, that is going to be square root of 5. Okay. Now for 10, what we can do? For 10, how the calculations can be? Now 10 can be written 5 plus 5. Okay. So square root of 5, here also you can do. So if you are getting 10 as 5 plus 5, and so 10 is what? Square of 10, square root of 10 is square root of 5 plus square root of 5. Like this also you can do. So taking this as base, and you can have a right angle. Means you can have a right angle where the base is square root of 5 and height also square root of 5 to get square root of 10. Okay. This is one way. But one more way, I think it is easier. And if you want only square root of 10 directly, if it is not, square root of 5 is not asked, then specially what you can do, 10 can be written as 9 plus 1, and 9 is a perfect square and 1 is also perfect square. So square root of 10, its square is equal to 9 is the square of 3 and plus 1 is the square of 1. So if you have, another way is what? Suppose you are having this base as 3 and height as 1, still you can get this hypotenuse to be square root of 10. So to get this base 3, you can draw a right angle at 3 also. Okay, it's another way. And then height can be taken as 1. So base 3, height 1, you can have another right angle triangle this, where this distance is going to be square root of 10. And when you take this distance in with your compass, and when you have this arc over here, wherever it intersects, it is the square root of 10. Okay, like this you can show square root of 5 and square root of 10 on the number line. Now to go for the next question, it will not be too much time consuming. We will go through it quickly. Question number 4. What is this question number 4? Now it is related to the rational numbers. Write any 3 rational numbers between the given 2 numbers below. Now we know already that there are infinite rational numbers between any 2 rational numbers. But these rational numbers are given in the decimal form. How to get any 3 rational numbers, we have to see. Now this type of questions are a little bit open-end. You will have multiple answers, and if your answer is satisfying the given condition, then your answer is correct, otherwise wrong. So first thing here, question number 4, the first number is given 0.3 and minus 0.5. Okay, so you can see that minus 0.5 is negative, it is going to be smaller than 0.3. Okay, so this is going to be smaller than that. Just try to get relation between which is smaller and bigger. Now, so if you think on the number line also, suppose here 0, this is 1, here somewhere you will have minus 0.5, you will have 5 parts, 5 parts, 1, 2, 3, 4 and 5. Okay, and here also if we take this is 1, this is 0.5 positive, so 1, 2, 3, 4. So 1, 2, 3, 4, 5. So 1, 2, 3. Here you will have 0.3. So how many numbers are there actually in between? We have minus 0.4, minus 0.3, like that. 1, 2, 3, 4, 5, 6, 7, 4 here and 2 here and 0. So total 7 numbers are there which you can write. Means you can write your answer can be written as, you just go on in increasing value, ascending order. Here minus 0.5, you can write minus 0.4, minus 0.3, minus 0.2, minus 0.1, 0, 0.1, 0.2. I have come till 0.3. All these are numbers between, correct? These are the rational numbers between 0.3 and minus 0.5. Now out of the 7, you can write any 3 whichever you want. Okay. So like this you can write. So this way you can understand with the help of rough figure, and then you can write. Okay. Now come to the second one. Minus 2.33. 3 and minus 2.3. Now here after decimal you have only one digit. But here you observe that it is 1 digit and here 2 digit. So it is difficult to compare. So what you can do, minus 2.3 you can write as minus 2.30. So what we have done, we have added this 0 and we have made this 1 digit after decimal into 2 digits. Now we can compare, and now it is minus 2. If you want to compare which is bigger and smaller, but if it just become third, after this is 30 and this is 33. So you can get 2 numbers in between easily. Minus 2.31, minus 2.32. But we want 3 digits. 3 rational numbers. So we don't have this. So what we can do? We can put one more 0. Okay. So we will take minus 2.300. We can add as many numbers we want. And minus 2.33, we can write it as minus 2.330. So here we have added 2 zeros after this original, and here we are adding 1 0. In all, we have 3 digits after the decimal. 1, 2 and 3. Here also 1, 2 and 3 digits. Now if you see, this is after decimal point, if it is 300, that it is 300, and here after decimal is 330. So you have 29 numbers in between. This 2.301, 2.302, 2.303 up to 2.329. Of course, they should be negative numbers. So you can write any 3 numbers between 301 to 329. Okay. So your answer can be minus 2.301, minus 2.305, like this, minus 2.312, like this. Any 3 numbers are 3 rational numbers between the given rational numbers. Like this you can do. So this is the key point, that after decimal, if you do not have same digits, you can add number of zeros as many as you want and make it safe, and you can get any 3 numbers in between. If you have understood these 2 sums, easily you can do the remaining 2 sums in this method. If you understand this, please give likes, give your comments. Your comments are welcome, and forward these videos to your friends. And if you are not yet subscribed, please subscribe. Thank you.